So, you've been up late at night on eBay looking at cool music gear, and then all of a sudden you see a console module come up. It's got EQ, it's basically an entire channel strip from a console, and maybe it's an SSL, maybe it's a Neve, maybe it's whatever. You can find tons of Neve modules on eBay. And you see, oh wow, this is like 50 bucks. It's $100. Let's buy it and see what happens. So you buy it and it shows up. Now what do you do with it? Well, what we're going to do in this video is we'll kind of set some expectations on what you should be looking for and how it might pertain to your usage case, because you really need to pay attention to how you're going to use this piece of gear. And then we'll also look at how you can reverse one of these console modules, because in a lot of cases you will not be able to get schematics for these, and you generally don't need them. You can just use some basic troubleshooting skills to get audio in and then get audio out. And this will kind of come back to the expectation setting to how are you going to use this? Are you going to need more than one output on this thing? Are you going to be running to a patch bay? Are you going to be running to like a patch bay and then going to other outboard gear? Or are you going to be going to just a digital console and going to the aux in to bypass the internal preamps? So that can dictate what exactly you're looking for. Now, in a lot of cases with these old analog consoles, they've got auxes, like you've usually got at least a couple auxes and then subgroups. So you generally should be okay with having like plenty of routing options, but it's just something to keep in mind. Another thing is going to be size. A lot of these large format consoles, the modules are kind of big, like they're really tall. And I've actually got a few that are 21 inches, 23 inches tall or wide, however you want to look at it. So it won't fit in a 19-inch rack. You'll have to do a custom enclosure, and that won't be covered in the scope of this video. That's something that you're kind of going to have to decide on your own. So what you can do is, if you see something and you're not sure, just see if you can message the seller, and then a lot of the times you can just tell if a module looks kind of big or kind of wide. You can usually tell that it's not going to fit in a rack enclosure. So anyway, these I kind of lucked out on. They fit perfectly. This one you kind of have to do sometimes. You kind of have to do some creative mounting, like this one. It's actually offset. It's standing up a little bit. I've got some bushings back here, and I had to add these little wings to get this to fit in because the circuit board is wider than the circuit boards on these, and I had to kind of offset it a little bit. So anyway. So once you have your usage case scenario figured out, there's a few other things you need to look at. I sort of, again, lucked out with these modules. All of the chips on there, these are all IC driven. They don't have discrete transistors. These are all socketed, which makes troubleshooting very, very helpful. If there's a bad op amp or a bad chip or whatever it is, you can just pull it out with some pliers and then pop a new one in, no soldering. Nothing like that. So that is something to consider if you're not really wanting to invest the time in troubleshooting transistors, and especially, in some of these, if they've got discrete transistors and they have certain matching characteristics, that can be a real headache trying to figure that out. So you might want to try to stick to stuff that only deals with op amps, for example. Another thing is that sometimes you may have to put up with an acceptable level of noise. This Harrison has kind of some idiosyncrasies with it where it will be a little noisy at first. When you leave it on for a few hours, it kind of chills out and it'll just kind of stop making noise. And I generally use this for guitar, so my signal to noise ratio is pretty good. Like I've got such a loud signal coming in, I can keep the pre back down a little bit, and the noise really isn't noticeable. I mean, even if you hit a chord and you stop, like you basically can't hear the hiss or anything. This is something that it'll register at the very bottom of the meter, and if you turn it way up, you can hear it, of course. But so sometimes, if you're getting an older console, especially when it's like been decommissioned from a TV studio or just a recording studio, some of them may be a little bit noisy, and you've got to decide how much time do you want to put into getting that as silent as you possibly can, and is it really worth it? So again, comes back to the usage case scenario. So from here, what we'll do is we will look at how you can reverse engineer these, and this is not going to focus on like drawing a schematic and knowing exactly how any console module will work. It will basically just focus on how are you going to get audio in and then audio out. And there's a few caveats that I'll put before I start all of this. If you're dealing with non-transformer coupled modules, so if it doesn't have a transformer between the mic input and the actual preamp, then there's some things that you need to keep in mind. So without the op amps, or without a transformer, what'll happen if you try to, for instance, if you wanted to wire up an XLR combo jack with a 1/4 inch, like a mono 1/4 inch tip sleeve plug, 1/4 inch plug, you're going to get some noise. And also if you're like trying to just DI like a bass or a guitar or something and you roll the volume knob down, you're going to get some really weird characteristics, like the volume will not be stable, like it won't be a very linear response, and you'll get some weird kind of like scratching with it. It's not a great situation, so you may have to add a transformer if you're trying to DI instruments. So for instance, I only have one Harrison channel strip, and I kind of, because I like how it has the Harrison EQ on it, I kind of want to use it for as many things as I can. And DIing guitar or bass is not very practical without having a transformer on there. So what I ended up doing was just getting a Jensen transformer, and I put a switch on the back that will switch between transformer for DI stuff and then just regular, like bypassing the transformer and going straight in for XLR microphone connections. So that's something to keep in mind, because those Jensen transformers they're really, really nice, but they're also really, really expensive. So that can basically double the cost of your of what you're trying to do here. So anyway, we'll go ahead and get into the troubleshooting, and we'll take it from there. We are here with the module after reverse engineering. It's all hooked up here, and I'll go ahead and demonstrate that it's working. I have a very dangerous setup here. I'm just running it off of the power supply of another thing. So turn it on, turn the logic on. You heard all the relays click in place, possibly. And I'll just show you on the scope here that it is indeed amplifying. Here is the first audio stage. It's just a buffer set there. I've just got a 3-volt peak-to-peak signal going in. So this guy works. Turn that off. So the first piece of advice that I will give you is, if you can, buy more than one. It is very helpful, once you've got this rigged up. I'm sure a lot of you will have the same issue as me, having it rigged up precariously. So it'd be nice to not have to flip it over. So having a untouched piece is always great to be able to flip over and look at the traces on the underside. Now, I will briefly sum up the steps needed to fire this thing up or to reverse engineer it, and then I'll look at them in detail. So first thing you want to do is find your power supply inputs, and in this case you got your positive and negative rails here, and then you've got your logic power input there. Then what you need to do is look up all your chips and see what their maximum power ratings are, because sometimes you may not have an indicator for for what your voltages should be. Next, you're going to want to look at your logic and probably turn that on first, especially if it looks like it controls other things. Like in this case, you have relays that control, that basically turn the circuit on or allow it to receive audio. So, verify your logic circuit. Once that's taken care of and you're able to activate these relays, you want to go in and basically what I always do is I just look for big electrolytic capacitors near op amps. That's almost always going to be a decoupling capacitor for the inverting and non-inverting inputs of the op amps. It's almost always going to be in between that and your multi-pin connector. So in this case, these guys are connected to these 100K resistors, which go all the way to pins 1 and 2, conveniently enough, of this connector. So you found the big electrolytic capacitors. You now know that you can pipe audio in to your op amp. And so then from that point, you need to go and figure out where the outputs are. Now, when I looked up all the chips here, I saw that these were analog switches, MOSFET switches. So I was like, wow, that's kind of strange looking, all these through holes here. So I just started probing these, and sure enough, that's the output of the circuit. Conveniently, that's your main fader output there, and then that's the other one. That's your stereo signal. So, and also these sends right here go to these. So like these are the master output section, and so that pretty much will get you there. Just taking those few steps. And so now we'll go ahead and go into some detail about, how do you actually find these physically and all this without a schematic. Okay, so you've just bought this. You have no schematic. You have no silk screen markings on the circuit board of what your voltages are supposed to be, all that. Okay, so you come in and you're trying to find your power rails. Now, in this case, it was easy, but I've worked on other modules and converted them where basically you just want to look for, as far as the power rails, just look for some big traces on the circuit board. That's almost always it. So sure enough, on here, you got your positive and negative rail and then your audio ground. Now this one was a little strange. I haven't personally seen this. This had its own onboard voltage regulators right here, so it tripped me up just a little bit. You got your PC mount fuses right here, there and there, and they obviously come back to your multi-pin connector. That's another good indicator, is if you see the pins doubled up like that, that's probably going to be some kind of, high current, big boy power input. So again, it threw me for just a little bit of a loop because they come over here and they hit the voltage regulators. So this is just a 7818 and a 7918, or yeah, I assume I have those right. I can't really see from right here, but yeah, they're both 18 volt positive and negative regulators. So on previous things like this Harrison preamp over here, I was able to just go from, the power pins straight at the connector and just go continuity check to the power pins of the chips. In this case, I had to go over here and verify that it was going here, and then these regulators jump over to the power pins here. And so sure enough, you can verify with continuity check that these rails go to the positive and negative pins of all the audio chips. So cool, that's figured out. I now know where to, or you will now know where to pipe in your high voltage. Now, this is what threw me for a loop on this guy. So you have here your logic pins, and you have relays. So I'm thinking to myself, well, I should probably try to fire up the logic side of this before I even put in the positive and negative 18 volts on here, because I don't think any of this is going to work because of these relays, and I can almost guarantee you these relays are driven by some kind of logic. So go over here to the logic section, and it's important to note on here that your logic stuff is almost always going to have digital ground. It's going to be an isolated ground from your audio ground, and that is the case with this. And so the easiest way to figure out your ground plane is just go to your logic chips and just look where your ground pin is going. And in this case, these are logic gate chips here, and that was easy enough. Found the ground plane on here. And then as far as the power supply voltage, I looked up the data sheets for these, and they'll run at like negative 1.5 volts all the way up to like 22 volts. So it's kind of like it's a fairly badass chip. It just well, I'll get to that. So it's got a wide range of voltage that it can take. And so I look here at my power supply, and I tried to ohm it out, go to the power supply pins, and I noticed that it wasn't a dead short, so they had something in between. which ended up being this guy here, which is a MC78L08, I believe. Yeah, 78L08, which is it's a low current 8 volt voltage regulator. So I'm thinking, okay, well, the other end of it, the output pin of it, is connected right to the rails, and I'm thinking, okay, I guess they're trying to run this chip at 8 volts, which, you know, this thing dates to 1994. Higher logic voltages could be a thing, I guess, and so I try running the thing at 8 volts. I just tried to hook up 8 volts. Where did I do it? I think I did it, yeah, right here. Whoops. Right there, and then I just had the ground pin connected. I want to say it's that. I think that's my logic ground pin, so I just hooked up some alligator clips. Actually, I'll show you right here. This is exactly how I hooked up to my power supply. So yeah, got your logic ground right there, and then I just did it right to the connector. So, hook it up, and nothing really worked. The lamp on the channel activate switch worked, so this guy right here, that worked. And then I noticed that this is an over limit light here, that was stuck on. And I was like, okay, well that's strange. There's status indicator switches on here. It's like in switches, like none of these were working. And the PFL, LNR right here, mono, none of that stuff was working. I was like, okay, that's a little weird. I mean, I assumed that I was running them at the proper voltage, but I was not. So what I ended up doing was I started probing across the LEDs, because you need about 2.5 volts or 2.2 volts to turn on an LED. And so I'm measuring across them, and I'm noticing that I'm getting about 40 millivolts, which is not enough. And so I'm thinking to myself, okay, well, there's not enough voltage in between them to turn them on. And so what I start doing is I probe from one side to ground, or to logic ground, digital ground. So, you know, on this side I'm getting 8 volts, and on this side, on the other side, which I believe is the cathode, on the other side I'm getting, depending on the position of the switch, I'm getting 8 volts or 6.2 volts. And I'm like, aha, well, so they're probably just doing a difference in the voltage of the positive rail. Well, there's only one rail, but of your voltage rail to turn on the LEDs. So I'm thinking, okay, well, maybe this chip is supposed to be run at a higher voltage. It is, all these logic gates are supposed to be, I mean, they're good up to 22 volts. So I just start creeping the voltage up with my power supply. And as I'm doing that, I start to hear some of the relays click over. As I increase the voltage, I just keep on hearing click, 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 because all these are starting to turn on. This guy over here, all the relays are starting to turn on, and I'm thinking, okay, well, I'm doing the right thing. So eventually, sure enough, I creep it up to 18 volts, and everything fires up. Like the relays have stopped clicking over. All the switches have finally lit up, because I just had them all depressed. So they all click over, and that's working. I'm thinking, okay, awesome, I've got that figured out. A little strange that, you know, the logic voltage is 18 volts. I would have expected that to be 5 volts. You know, I think most people here that are familiar with TTL chips and doing digital electronics, you know, you're dealing with 3.3 volts, 5 volts. And that was the case on this guy here. This is another console module from a Harrison, and all of its logic stuff just runs off straight up 5 volts. So that kind of threw me for a loop on this guy, but this one's a little bit older than that. So, you know, I obviously wasn't there back in the day, so I don't know why people did things the way they do them. Anyway. So, logic fired up, awesome. These relays are working, so now I know all the connections are made. So, I now have my power supply rails figured out. I can pipe I can pipe my voltage to them, fire up all the audio end of the chips here. And it's important to note that, remember, the audio ground is going to be different than your logic ground. So you definitely want to make sure that if you're probing the logic stuff, make sure you're grounded to the logic ground, and then if you're probing your audio stuff, make sure you're at the audio ground. So what I started doing then is looking at just looking for some big electrolytic capacitors. Usually they're between 100 UF and 47 UF, and the voltage is almost always 50 volts. And those are almost always connected directly to the multi-pin connector. So in this case, what it ended up being was the relay was in between the capacitor and the inverting and non-inverting inputs of the op amp, and they are connected in series to these 100K resistors. And then you can actually see here, once I saw that they're connected to these resistors, I see these two little traces go up through here, and then you can see them just trace the two right above this big fat trace here. They go, sure enough, to pins 1 and 2 on the multi-pin connector. So at this point, I'm like, okay, great. I can get audio into the board, and then it's going to be a cakewalk from here. So what I just ended up doing was just tacking on some leads to the underside of the board here at the multi-pin connector. Right there. And then I just had my signal generator hooked up to those, just bare wire. That's obviously not anywhere close to being done, but this is just for the reverse engineering. So, got my audio hooked up. I'm thinking awesome. And I'm over here. And, you have to keep in mind that this is a stereo input module in this particular case. A lot of you are probably going to be dealing with a mono channel strip like this Harrison here. So I'm thinking, okay, well, it's probably going to be this op amp here, and I've got my audio coming in. I know that it's hitting these capacitors, and I know it's hitting the non-inverting and inverting inputs, and I'm probably going to be looking for an output. So I took my scope, I fired everything up, turned on the logic, turned on the B+, or your positive and negative supply, and then I just looked at the output pin of this first stage here in the amplifier. And sure enough, it's passing audio. So cool, awesome, it's passing audio. And so now that I'm getting into that, I'm thinking, okay, well, I'm assuming that this whole thing is probably working at this point. It doesn't need any repairs or anything like that. And even if it did, all these chips are socketed, so it's replaceable. So I'm thinking, okay, I've got an input confirmed. Now I just need to go look for an output. And this is where, researching your chips will come into play. Once you've looked at your chip voltages to kind of see, where you can run them, then you kind of have an idea of what they are. Like a lot of these I'd never even heard of because these are old obsolete chips, but these are analog switches. So from doing my research on the chips and knowing that these are all analog switches, I immediately come over here and I'm like, this is probably my output section, coupled with the fact that they have all these through holes right here that are just ripe for probing. So I kind of just took an educated guess and I put my scope probe on here, and sure enough, that's the main fader. That's what these control is that output. So you got your main fader left, right, and then it also, a couple of these are the basically like aux sends or sends. And that pretty much did it. I mean, that figured it out. And as you recall in the beginning of the video, when I showed that it was working, I probed, I'm not sure if I showed it, but I probed that exact thing right there. And that can be a little tricky sometimes, if you're trying to hold a scope probe and there's nothing to hook onto, if you've got like the hook lead on the scope probe, it can be kind of tricky to, hold it on there and then also manipulate the controls to verify that, that's actually the output that you're looking for. Because because, you know, I'm sure most of you that are looking at racking a console strip are probably going to be trying to use the main fader output. Maybe you're trying to use the aux output, I don't know, but I know that it's always my objective first to get the fader to work. And that doesn't have to be the case. Like, you don't have to go for the fader. That's just personally how I do it, and that's kind of how I mentally work through it. Is, you know, okay, well, I've got the fader working, so I kind of know that that's probably the most complex part of the circuit. So that's pretty much, you know, in my opinion, a good way to get from having no schematic and then getting a working module out of this. So, you know, from here, what you'll need to do is build out a power supply and, you know, have a panel on the back where you'll want to have a power switch. You want to have a possibly an impedance switch. I kind of did it sort of goofy, like on this one, because I wanted to have like an instrument input, and so I put a transformer, and you can just switch between the transformer and the mic input. So you'll need to kind of just do, you know, administrative stuff like that. Yeah, so to kind of sum this up, you basically want to find out where your power rails are, because, you know, you're not going to be able to do anything unless you have your power rails. Figure out your power rails, then figure out if it has logic. Okay, if it has logic, then you probably are going to want to turn the logic on first, because in this case you've got solid state switches over here, and then you have mechanical relays over here, and so you can kind of just assume that none of this is going to work if you don't turn on your logic first. So figure out your logic. Figure out the maximum voltage ratings of your chips, because you may not know what voltage you want to run them at or what they're supposed to run at. And then you got your voltages figured out. Like I said, turn on the logic. Once you verify that the logic works, try to find some big electrolytic capacitors that are near op amps, and then trace them to, you know, your multi-pin connector, and then see if, you know, you can get them to see if they're connected to the input of the op amp. Then pipe your signal into the op amp and into the first stage of your circuit. Look for the output, and then once you've done that, you can pretty reasonably assume, in my experience, that the circuit is going to work, and then you just start looking for outputs. And again, if you've done your research on the chips, you'll know that these are switches, and that's probably an output section. So, all right, and that concludes this video. I appreciate you guys checking it out, and I hope you learned something. I have two CADAC F-type console modules that are coming in, and I'm gonna do a video on those from the ground up. So this one I kind of started in the middle of my troubleshooting process, and what I'm gonna do in this next video is I'm just gonna start from, as soon as I plop it on the bench, I'm just gonna start rolling the camera, and I'll just edit everything down, and you'll kind of get an idea, because I do not have schematics for that. I've already checked; they are not available, at least that I can find. So we'll go down the rabbit hole with that and see how that is. Now, those are a little bit more interesting because they have the XLR jacks already attached to them. It's like a 90-degree thing, so the channel strip is like this, and then you've got the output jacks like that. So stay tuned for that video. I think that one will be interesting. And I just want to give some final thoughts. What you saw in the video, that was all of this stuff kind of before I put it in this enclosure and before I got a proper power supply and everything for it. Now that I've done that, there's two power supplies in here. There's a logic power supply that supplies the 18 volts for this, and then there's obviously the plus and minus 18 and 15 volts that are for these different modules. So these take 18, and then this takes 15. So I have to have regulators for this. These are unregulated from my power supply because they have the onboard 18 volt regulators. So once I ended up doing all this, I'm still having some issues with the over-the-limit lights are still stuck on. The LEDs seem to be at basically the proper brightness, so it might take a little bit more troubleshooting, but it's kind of something to keep in mind. You know, once you do all this troubleshooting and testing, and then you actually go to the trouble of getting a power supply and wiring it all up, you may find some things that still need a little bit of work. I also, with these being stereo input modules, one of the XLR connectors, I actually, because I copied them both, I copied the wiring from one to the other. I have the left channel is out of phase, so I have to go back and have to reverse the phase on that. Luckily, there's phase reversal on here, so when I have it plugged into the console and I'm playing stuff through it, I can just hit the phase reverse button and it works and sounds just the same. So it's gonna be a process. Like I can pretty much guarantee that no matter where you end up with this, you're gonna do a bunch of work, you're gonna wire it up, you're gonna get it all good to go, and then there's probably gonna be something else that happens. So don't get discouraged. It's just kind of part of the process, and it's pretty much gonna be different every time, because if you're going from manufacturer to manufacturer, depending on how they design things, you might run into ground loops and all this sort of stuff. So, but at the end of the day, it is pretty worth it. I mean, nothing sounds like this old gear, and it really is quite fascinating to see how these things were built and the design techniques that were used and all this kind of stuff. So anyway, once again, stay tuned, subscribe, leave a comment, let me know if this is the kind of content you want to see on this channel, and I hope to see more of you guys around.